right, we are going back to limits, and we're going to learn something new in terms of solving some of these. But let's just first remember how to do limits. What we said was if we plug in a number first, so if I plugged in 2, I would have negative 4 up top. Let's make it a color we can see. Negative 4 over 12 on the bottom. Your answer for this limit would just be negative 1/3. And this one, if I plug in 3, I'm dividing by 0. But I could cross out these things that cancel, and now I can plug in and just get 3. In this one, limit as x approaches 0. 3 divided by 0, we said we can't do. That's undefined. However, what we're going to say is this is dividing by a a really, really small number. So what that means is, if I did 3 divided by 1, that's 3. If I did 3 divided by 5, that would be 3/5. If I did 3 divided by 100, that's going to be, 3 over 100. It's going to get smaller and smaller and smaller. So let me go in the other direction. If I do 3 divided by 1/2, that means 3 times 2, which is 6. Or 3 divided by 1 over 100. That's 3 times 100, which is 300. I keep getting a much bigger number, so as my denominator gets smaller, my whole thing gets bigger. My limit is infinity. In this case, I have negative 2 over 0. That means I'm going to be a negative, but a big number, so negative infinity. And this last one here, if I plug in a 1, I get 0 up top, negative 1 on the bottom. Well, 0 divided by anything is just 0, so my limit is 0. So that's how I can possibly get infinity for these possible answers. Now, just to say a couple more, e to the 0 is 1. 1 divided by 0, we said was infinity. In this one here, I got to see, I can factor this. X minus 2 over x plus 2. X minus 2 on the bottom. Now my x minus 2's can cancel, which just leaves me now I can plug in my 2 and get a limit of 4. In this one here, I have 1 over infinity squared. Well, infinity squared is just infinity, and as we just said, if I keep dividing by a bigger and bigger and bigger number, the more pieces I divide a pie into, the smaller they get until eventually I don't have anything left. It's just little crumbs. Alright, and this last one, e to the 0th is 1 minus 1 and then divided by 0. So I have 0 divided by 0. Well, if it's 0 up top, we said that it was 0. If we had 0 on the bottom, that meant it was infinity. So what gives? What's our answer? This right here is what we call an indeterminate form because we don't know what it is. We don't know if it's going to be infinity or 0 or possibly something else. So this we don't know how to do, but using L'Hopital's rule, which all that means is if we have an indeterminate form, 0 over 0 or infinity over infinity, all I need to do is take a derivative of both the top and bottom of the fraction, and then I can go and solve my limit and if it will work. So, to see how that works, in this first one, sine of x, if I just plug in immediately, that's what I should try first. Sine of x is 0 and x is 0. So I have the indeterminate form 0 over 0. So what I'm going to do is I'm going to take the derivative of the top. I'm using L'Hopital's rule, that's why I put that h there. Cosine of x over derivative of the bottom is 1. Now if I plug in, I'm going to get, very simply, cosine of 0 is 1. Obviously this is still 1, so 1 over 1 is my answer, which is 1. So that's all you need to do is to take the derivative. Now in this one, plugging in infinity. E to the infinity is infinity. X squared is infinity. So I need to take a derivative using L'Hopital's rule. So this equals, I should always write the limit as x approaches infinity. Actually, I should have done that up here as well. Let me insert that because that's very important. It still is the limit as x approaches 0 in that case. So in this one, now I've taken the derivative of the top, it's still the same. Derivative of the bottom is 2x. Let's try plugging in again. E to the infinity is still infinity. 2 times infinity is still infinity. Well, now what? Well, guess what? I can take that L'Hopital derivative yet again. So when I do that, I'm still doing the limit. Top is still e to the x. The bottom is now 2. Now if I plug in, I have infinity over 2. Well, what's a big, huge number divided by 2? It's still a big, huge number. Now I can do my answer. Alright, in this one, if I plug in 0, e to the 0th power is 1. So I have 2 minus 2 is 0 up top, and 0 squared is 0 on the bottom. So I can use L'Hopital's rule, and I can say this equals the limit as x approaches 0. If I take derivative of the top, I'll just have 2e to the x over 2x. Okay, at this point, well, first of all, I can simplify the 2's. They can cancel each other out. And let's see what I have left. If I plug in 0, I would have e to the 0, which is 1, over x 0, which is 0. So that means I have 1 divided by 0, which means my answer here is infinity. And here, my last one, if I plug in negative infinity, e to the negative infinity is 0. 6 times negative infinity is negative infinity. 0 divided by negative infinity. What's that? Well, I don't even need to use L'Hopital's rule for this one. Because if it was a top 0, you would think it would just be 0. And anything divided by a big, huge number is 0. So either way I look at it, I get 0 as an answer. So there's your look at L'Hopital's rule. This last one especially, don't take the rule until you know for a fact that you have to. And here's the other thing that we'll look at in our next video. 0 to 0 and infinity over infinity are the only times that we can use L'Hopital's rule. There are other indeterminate forms like 0 to the infinity, 1 to the infinity, infinity minus infinity, 0 times infinity. These ones do not work. We want to stay away from those. These are the only two that definitely will.